All right. Today we'll continue working on the Star Wars theme project and try to make the stars moving. In order to make something moving on the screen, we need to keep erasing the object and redraw it slightly shifted towards the direction of motion. The idea is the same for moving images or canvas drawings. The first change that we have to make to our page is making it remember the position of each star. Currently, we draw the stars, and we draw the Death Star, but we don't remember any of these positions. And we need to remember the positions to calculate a new position on each step of the motion. For the stars, we need to remember X, Y, and the radius values. We generate these values, but we generate them here. So X, Y, and radius, but we do not keep them. Now let's update our for loop so that we actually stores the values of all the stars. So I added two variables here. The variable n stars, which is just a number of how many stars we want on our screen. And stars it starts off as an empty array, but it is an array which will store all the data on our stars. So here in the for loop itself, it repeats while I is less than n stars, number of stars. So it will repeat this number of times, essentially. And every time it repeats, it checks if the length of our stars array is less than n stars. So we have less stars than we actually want. And in that case, we add a new star to the array. To add new elements in arrays, we use the push function. And here we pass in the element that we want to add. And in this case, we're adding an object in JSON format to the array. Now, you may remember that in Microbit, we tried putting all our data on songs in JSON format, but that did not work in block mode. But here we're working in plain JavaScript. And so this is probably the most efficient way of doing it in our case. So this object has three properties: X, Y, and radius. The X is a random position, a random horizontal position on the screen. The Y value, the Y property is a random vertical position on the screen. And the radius is a random number from 0 to 1. And in here, we kept our begin path function call, as well as our arc function and our fill function. But in our arc function, we draw the stars X, the star at its X position, Y position, and then for the radius, we put the star's radius, and then we add the minimum radius of 0.3. Also in JavaScript, if you're writing decimal numbers, where the number before the decimal place is 0, you don't need to write that 0. And it won't, and it'll still work the same. So, for example, if you want to write 0.3, you can just write 0.3. Similar idea here. If you have zeros after the decimal place, and only zeros after the decimal place, but you still want the number to be a decimal, you can just write 0. and you don't need to write the zeros after, and it'll still work as it should. Now, if we refresh this, nothing really has changed visually, but the big change here is that we actually store the position of each individual star. Well, its position as well as its radius. Now, before we continue working on the stars and making them move, let's temporarily remove our Death Star image. And instead of just erasing it from the code, we can surround it with these tags. And what that means pretty much, this tag pretty much just tells the HTML code to ignore whatever is between them. And this is useful for when you want to disable a line, but you don't want to delete it because you want to add it back later. Now, if we refresh our page, same as before, except we don't have the Death Star. Now, if we want to make an impression that the user moves forward through space, we need to move the stars away from the center of the screen, along the line between the center and the star. So for example, if we want to move this star, we need to move it along this line. If we want to move this star, we need to move it along this line. This star along this line. This star along this line, and so on and so forth. We also need to call this for loop multiple times within a time interval, and every time we change the position of a star a bit. So we can't put this for loop inside of another for loop to actually move the stars, because the browser, we need to actually wait every iteration of a for loop for the browser to catch up and actually draw the stars. So if we put this inside of a for loop just without waiting at all, the browser will wait for the for loop to finish working and then render the stars. And we want the stars to be drawn for every point of motion. And for that, we will use a JavaScript function called setInterval. And what this function does is the function that you pass in, it will repeat every certain amount of milliseconds that you pass in here. So in here, we pass in a function. And this function will be cycled every 20 milliseconds here. And so every 20 milliseconds, we will call this for loop. And this for loop will draw our stars. I also added this speed variable. And this will just be a coefficient of how much we want to move the stars each time. And now, these two lines of code will actually change the positions, calculate the new positions of the stars. So here, to the x position, we just add this value. And So in here, this is just the position, the star's X position from the center of the screen. So at the very center, it's 0, and then if it's to the right, it will be positive, and it'll get bigger the more right you are, the farther right you are. And similarly to left, it'll decrease the farther left you go, and it'll go into the negatives when you go left. Then we multiply this by the star's radius. And we also multiply by the star's speed. So multiplying by the speed is because we want to actually control the speed of the stars. And we multiply by the radius because if the star is big, that means it's close. And if it's close, it'll move out of our field of view faster. And also, the reason why we're adding pretty much the distance away from the center is because the farther the star is to the side, the faster it should move out of our field of view because it's farther away from us. Whereas the stars in the center, we're moving towards them, and so they shouldn't move away as fast. And now, similar idea here, but with the y values. Now, let's see how this works. It looks cool, but it's not exactly what we want. It kind of looks like we turned on hyperdrive on our spaceship. And we're traveling faster than the speed of light. So, but at least, as you can see here, our logic is actually working. The stars closer to the center don't move as fast. The stars closer to the sides move a lot faster. The stars also move away in all directions away from the center. And also, farther stars move less fast, move slower than some of the closer stars, which are actually already gone by now. Now, the reason this is drawing these lines is because we're never actually deleting the previous star. And so we kind of have this trail behind the star, pretty much indicating its previous positions. Now, to fix this, we need to actually delete the previous star before drawing a new one. And we can do this by painting over the previous star with black. Black because it's the color of our background. So here we do begin path, similarly to here. And this is pretty much the same as this. We paint pretty much the star's X and Y position, but this is before we calculate the new position. So this is the old star. And for the radius, we increase the radius by 2, just so we actually cover the entire star. And we fill it with black color. Now, in here, we're going to need to add this line because previously we're painting over the stars with black, and we actually want to switch to a white color. And we can actually remove this from here entirely. Now, if we refresh this, the previous stars are being deleted, and the stars render normally. Now, let's actually make the stars move a bit faster. So here, I increase the speed 10 times. And everything is fine at the beginning. We have a cluster of stars that move past us. but once we get past that initial cluster, there's no stars left in here. And that's because once the stars actually exit the screen, we don't put them back on the screen itself. And so all of our 500 stars are rendered somewhere outside of our window. Now, let's make the stars reappear. And to do that, we're going to add an if after we calculate the new position of the star. So in here, we pretty much just check if a star is outside of our screen. So here we check if a star's x value is less than 0, so it exited from the left side of the screen, or the star's x value is larger than the width of the screen, so it exited from the right side, or the star's y value is less than 0, so it exited from the top, or the star's y value is larger than the height of the screen, so it exited through the bottom. And now, if any of these are true, that means our star is actually outside of the window, and we need to draw it back on the actual screen. And so in here, we set the x and the y values of the star to a random point on the screen. Let's see how this works. So the stars, when they exit the screen, they actually reappear on the screen, but they kind of just pop like in the middle of nowhere, out of the middle of nowhere. And this is not very realistic. Instead, we need to make it so that the stars fade in gradually into the screen instead of just appear out of nowhere. And in order to do that, we need to keep track of when the star was painted on the screen. And from there, when it was initially painted on the screen, we keep the radius small, and then as time passes by, we increase it until it reaches its original radius. So in order to do that, we need to add a new property to our start object. And this will be a property time. And this will just represent the time when the star was created or reset. And in here, we pass in a new date object. And this date object pretty much just represents the timestamp when it was created, or in our case, when our star was created. And now in our if here, we need to add this line of code to so that when we reset the star, we reset the time as well to a new timestamp. And now, after that, we need to actually control the radius of the star. And here I'm going to add a new constant called radius. And in JavaScript, a constant is much like a variable. And the only difference is that variables, once you set the value of it, you can pretty much change the value as much as you want. But with constants, once you set a value, you cannot change it. And constants are good for when we want to store values that we know we're not going to change. And so in here, we set a radius constant to this formula here, which pretty much calculates the radius of the star with respect to time. So in here, we create a new date object. So pretty much this gets us the current timestamp. And then we use the get time function to turn this format into milliseconds. And so this pretty much gives us the current time in milliseconds. And here we take the star's time property, which is a date object. And then we use getTime on that. And so we get the time in milliseconds when the star was created. And by subtracting that from the current time, we get the difference in time in milliseconds. So the star's life in milliseconds, pretty much. And here we divide it by 1,000. So if the star existed for 1/10 of a second, this will be 0.1. If star existed for 10 milliseconds, it would be 0.01. And if a star exists for 1 second, this would be 1. And here we actually have this inside of a math.min function. And what this does is it takes two parameters, this and this, and then it chooses the smallest one out of them. And here we have our second parameter as 1. And so the reason we do that is after 1 second has passed, and this became 1, we don't want the star to actually grow past its original size. Because we multiply this by the star's radius, and so 1 times the radius will be the original size. And so by doing this, we kind of make it so that once this gets bigger than 1, then we just keep it at 1, or the star's original radius. And in here, we need to change this to our radius constant. And as you can see, when stars disappear off a screen, they slowly fade in, like these stars here. And now this looks realistic. Now you may be wondering, what would happen if I change this to something other than 1? Let's put 5, for example. Now the stars grow past their original size, and they grow to 5 times their original size. And so what happens here is, well, first of all, these stars become big. And second of all, since these stars are 5 times their original size, this function can no longer erase the entire star. So it kind of just cuts out the middle of the star. And we have this cool looking, I guess, comet pattern. Or it kind of looks like the Matrix, depending on how you see it. I know this looks really cool, not gonna lie, but that's not exactly what we want. So let's change this back to 1. And now this looks more realistic. It looks like we're actually flying through space. Now let's add several controls for speed and start numbers as well, so that we can change the speed as we go, and we can also change the number of stars. We'll also control the appearance of the Death Star, as well as the refresh interval. And to do that, in our HTML code, we are going to add a new table for our controls. And this table, we set the position to absolute, and we put it in the top left corner. And we also set the text color to white, because we can't really see black text on a black background. The white is a better color for this background. And in here, we have 4 inputs. We have a checkbox input, which will just toggle whether we want to see the def star or not. We have this stars range slider, which goes from 0 to 1,000. And that's pretty much, this controls how many stars we want. This speed slider goes from 0 to 1,000. And this controls the speed that we want to go at. And our refresh interval, also a range slider that goes from 0 to 1,000, controls our refresh interval here. And pretty much how many times per second, or I guess, how long do we wait between we change the frame each time. Now, after we add this controls in HTML, let's add variables. Whoops. Let's add 4 variables, and these variables will represent each of our controls. So this input ds variable represents our def star checkbox. This input stars variable represents our stars range input. And our input speed variable represents our speed slider. And last but not least, the input interval variable represents our refresh interval slider. And we do this using document.getElementById to get the object model of the element. Now, next thing we have to do is modify our for loop a bit, like so. And actually, since speed is regulated by sliders, as well as the number of stars, we can delete them. And so in here, what I did was I added the speed variable here. And the speed variable is just, the speed variable is the value of the input speed slider divided by this. And this is actually just a number, but in scientific notation. In JavaScript, when you write a number, doesn't matter, whole number or decimal, you can then put an E after it, and then a number after the E, and this pretty much just symbolizes multiply by 10 to the power of this. Or in simpler terms, add 4 zeros, in our case, to this number. So 1, so here we just have 1 with 4 zeros. And 1 with 4 zeros is 10,000. And so we divide this by 10,000. And the reason we do that is because our speed input goes from 0 to 1,000. And so we want our max value for speed to be 0.1. Because we don't want our speed to be too fast. And now, in terms of a for loop itself, here we loop, instead of through n stars, which we deleted, we loop through the value of the inp stars variable. Sorry, the inp stars variable, which is this stars slider. And same with our if here. We replaced n stars with inp stars.value. And now we should be able to control the speed as well as the number of stars on our page. And here, these are our controls. Here we actually added our sliders. Now we can change the speed. Now, one thing I want to change off the bat is, as you can see, when we increase the speed a lot, The stars fly by so fast, they don't have time to actually swell up to their original size. And when we slow down, they all fade in. And to fix that, we need to change this value to 200. So it takes 200 milliseconds for them to grow to their original size. Now, when we refresh our page, let's add some stars. When we move at fast speed, stars still render normally. And also we can increase the number of stars, as you can see here. However, we increase the number of stars here, but when we start reducing the number of stars, a lot of the stars get stuck there and stop moving. And the reason for that is our for loop, in order to remove these stars, we need to actually delete them through here, but the for loop can't actually access that to delete those stars because we go to a much lower value. And now, in order to fix it, we have to make it so that when we change the number of stars, we clear the screen from all of our previous stars. And so to do that, to our canvas, actually, sorry, no, not to our canvas, to our stars input, we will add an event handler. So on input, event will add, and on input, we'll call the refresh canvas function, which we will create right now. And the refresh canvas function will be pretty simple. We will just call ctx.clearRect, which pretty much erases a rectangle. And here we call it from coordinate 0, 0, so top left corner of the screen, to the maximum sizes of the screen, so bottom right corner. And this will essentially just erase everything on our screen when we move the slider. So let's test this. So when we move a slider, it flickers a bit because it's erasing all the stars. But then, once we stop moving it, it stabilizes. And when we move it back, we don't have the same problem with the stars not moving. And yeah, that's all that we have time for today. Next time, we'll actually make it so that we can use these sliders, this slider and this checkbox, and we'll also render the Death Star in and make it approach with the stars. I encourage you to take this program and then play around with the different values in it and see what kind of cool, I guess, patterns you can, or cool motions you can create with these stars. So that's all that I want to explain for today. Are there any questions? No? Okay. Well, thanks for watching, everyone. And I'll see you next Sunday.